You press a button, wait a minute, and boom, hot food, like magic. But have you ever stopped to ask, what's actually happening inside that microwave box? This little machine turns cold leftovers into steaming meals in seconds. But how? Is it radiation? Is it safe? And how does it heat from the inside out? Stick around, because in the next few minutes, we're cracking open the mystery behind microwaves, and trust me, it's way cooler than you think. Don't forget to subscribe if you love simple science that explains everyday life. Let's heat things up. When we say microwave, we're talking about two things: the appliance in your kitchen, and the invisible electromagnetic waves it uses to cook food. Microwaves are a type of electromagnetic radiation, just like radio waves, infrared, or even visible light, but with shorter wavelengths than radio, and longer than infrared. They're not radioactive, and they're not dangerous, unless you're a water molecule. More on that soon. Here is where it gets wild. Microwaves don't heat food by warming the air or using a flame. They heat food by making water molecules shake like crazy inside your food. There are billions of water molecules. Microwaves are tuned to a frequency, about 2.45 GHz. That causes those molecules to vibrate rapidly. This vibration creates friction. And friction generates heat. That heat spreads out, cooking your food from the inside out. Or more accurately, from the water-rich areas outward. That's why foods with higher water content heat faster, and why a dry piece of toast doesn't microwave well. You've probably noticed that sometimes, your food comes out hot in one spot, and ice cold in another. Why? That's because microwaves don't always reach every part of the food equally. The waves bounce around inside the oven, creating zones of high and low intensity, called hot spots and cold spots. Most microwaves use a turntable to rotate your food and help it heat more evenly, but it's not perfect. Also, thick or dense foods heat more slowly than thin or soft ones, because the microwaves can only penetrate so deep, usually about 1 to 1.5 inches. The rest heats as the energy spreads by conduction. Here's the question that makes everyone pause: is microwave radiation dangerous? Nope, not if used correctly. Microwave ovens are built with shielding and safety interlocks so that the waves stay inside the box while it's running. The radiation they emit is non-ionizing, meaning it doesn't mess with your DNA like X-rays or UV light can. And no, your food doesn't become radioactive. It just gets warm. So don't worry. Reheating your coffee won't turn it into mutant fuel. You know the basics now. But here are a few things that might surprise you. Microwaves were discovered by accident in the 1940s, when a scientist named Percy Spencer noticed a chocolate bar melted in his pocket while working on radar. You shouldn't put metal in the microwave because it reflects microwaves and can cause sparks. Microwave popcorn bags contain a susceptor, a material that gets super hot and helps pop the kernels evenly. Some plastics shouldn't be microwaved because they can leach chemicals when heated. Always check the label. Microwaves change the way we cook, turning meal prep from hours into minutes. But more than that, they're a perfect example of how invisible science shapes our daily lives. They rely on physics, chemistry, engineering, and innovation, all hidden inside a small box on your counter. So next time you reheat leftovers, remember, there's a whole world of molecular motion and electromagnetic magic making it happen. If this video changed how you see your microwave forever, give it a like and subscribe for more everyday science explained. Science is all around us, even in your snacks.